Okay, so it's my pleasure to speak here in Kyiv. It's my first time in the city. I walked around the city yesterday. It was really nice and also nice weather. So I will start with a question. How many of you have been trying or are using Entity Framework Core? Okay, so most of the guys. I guess all of you are using the version 2.0. Because the first version, who has some good experience with version 1.0? Okay, nobody, great. It was more beta than actual release, but 2.0 is actually quite usable, and it's great to see that there is a lot of people who have been using Entity Framework Core 2.0 so far. Who has been using also Entity Framework 6? Okay, also most of the people. And do you guys use some other ORMs, like nhibernate? Okay, few people. Okay, and for example, Dapper? Okay, so this is great. I think everyone raised the hand at least once, so that's great. Okay, so let's look at the new features of Entity Framework Core 2.0. Maybe the few reasons why did Microsoft started over and started working on Entity Framework Core at the first place. So the biggest issue of Entity Framework 6 is for me that the code base is very old. So it was very difficult for Microsoft to deliver new features. If you remember, for example, the SQL Server 2008 introduced geospatial types, and it took a lot of years until they were actually supported by Entity Framework. It was because many reasons, and one of these was the monolithic architecture of EF6. Also, the code base was spawned by legacy APIs. Maybe some of you remember object context. Yeah, so there are two APIs for doing the same thing. The old API, object context, which was bound to EDMX diagrams you could use in Visual Studio. And then with code first, a new API, DB context, emerged. And there was two APIs in the same library, which was very unpleasant. And of course, EF6 was designed for desktop applications or for server applications. So the memory footprint was quite high, and also this application startup time wasn't really perfect, which doesn't matter much for server applications, but if you want to use Entity Framework on the mobile devices, it would be a huge problem. That's why Microsoft started with EF Core. So it's implemented basically from scratch. Not everything is from scratch, but most of the implementation and the architecture is very different. And EF Core is lightweight and extensible, so it should be much easier to write new data providers for Entity Framework Core, so there is a lot of new stuff coming. And also it's compliant with .NET Standard, it's supported on Linux, and also in Xamarin, for example, in mobile platforms. And the big news for EF Core is that it doesn't only take care about classic relational databases, but it should support also non-relational data stores. I will be mentioning this at the end of the session. The current state, as you all know, is that some features from EF6 are missing. Who is unsatisfied with the number of features present in EF Core? Is there something you are really missing that you were using in EF6 and now it's not available in EF Core? Okay, lazy loading. Who cries for lazy loading in EF Core? Okay, not many people. Okay. Oh, there's one brave guy. Okay, great. And also, but there are a lot of new features that are only in EF Core and they are not backported into EF6, which may change in the future, but it will take some time. So current stable version is 2.0, and 2.1 is in preview 2. The preview word is very important because I will show you some bug I have found when I've been preparing for this session. So they are saying that there will be 2 or 3 other previews before the final version will be released. So, and they want to have 1 preview per month or something like that. So we can expect the new version 2.1 in the RTM in about 3 months or something like that. Yeah, so that's the time frame. So there's a lot of new features. I have picked only the most important ones. So I will have a demo for each of these features. And if you want to see the rest, it's quite nicely described in the documentation. As you may notice, in the last 2 years, the quality of documentation for old and new stuff has improved very dramatically. And new website docs.microsoft.com is very nice to use. So great job. OK, so the first feature is data seeding. Who has been using Entity Framework migrations? OK, at least half of the people. OK, great. And how did you seed data in your database? Have you been using that add or update on the context? OK, few people. And the other ones, where you been using manual SQL commands in the migrations to see data? OK, few people. OK. So in EF6, there was ways how to get some initial data in the database. But if you tried to use it, it didn't work well with the migrations. And this code was also executed every time when the application started. So if you wanted to create some, for example, initial users or initial data in some tables, it wasn't very perfect. It was possible, but there was a lot of problems with this approach. And data seeding is a new feature of EF Core, which allows you to specify some initial data for every table. And this is part of the migration process. So if you add new data using the data seeding features, a new migration will be generated, and it will generate also the insert, update, or delete statements, which is great. And also there is the reverse logic when you want to unapply the migration and revert to previous version. It will also fix the data. So this is a great thing. And let's look how it works. So I have a very easy demo. I will be using the very simple database. So I have a table with blocks. So that's block, it just has ID and name. And every block has a collection of posts. So there is the post entity. This is an article on the block side. So title, content, the date when it was published. And there are some comments. And of course, this is the details of the comment. And here's the DB context. So I will make this on the full screen. So I have these 3 tables. And specifying the default connection string. Of course, this in the real app, this should go to the configuration. It shouldn't be hard-coded in the on-configuring method. And here is my on-model creating function. It's overridden because it's the default implementation is part of DB context. And you can use the model builder API to specify default data for the tables. Here I'm seeding the blocks table. So I say model builder.entity, the type, which defines the table I'm working with. And there is a Fluent API, Fluent syntax, to specify the data. So I can say has data. And there is new block, ID1, entity framework team block, and etc., etc. I'm doing the same thing for the other tables. And that's it. And if you look at the migrations, I have created the first migration. So there is creating the tables. Yeah, so. And there is a new syntax which says migration builder insert data. So this is inserting the data right inside the migration. And now what happens when I add, for example, a new block? So let's do that. So ID equals 3. And this will be, for example, SQL Server team block. Yeah, so I have changed the data that should be seeded, and now I can use the classic approach at migration, and it should detect. Yeah, I forgot for the name of the migration. So new block, and it should compare the model, including the data. So it will notice that there is new block, and it will generate the migration. Yeah, so it's here. And of course, the complete model is stored in this blogging context model snapshot. Do not delete this file. It's very important for the migrations to work correctly. And this is basically serialization, the representation of the entire model. And this file is used by Entity Framework to compare what has changed in your model. And the great improvement, and it's not a new feature in 2.1, it's a new feature in EF Core itself. But in comparison to EF6, this works much better in the team environment, because if two people in the team add their own migrations, this file can be merged. Yeah, so you just use the classic source control tools, some WinMerge or something like that, to merge the changes, and the migrations won't break. In EF6, this was impossible because the snapshot of the model was base64 encoded, gzipped representation of the model, which is unmergeable. Yeah, so that's the improvement, and this quite nicely works with the data. Of course, if I decide to edit something, so for example, if I rename some existing block, it will generate the update expression. Deleting is always a problem, as you know from the relational world. So if you need to delete some things, you will probably not delete the block, but you will add the isDeleted column or deleted date or something like that. But that's classic SQL approach. We have to use this soft deleting mechanisms. Okay, so let's revert this because other demos would break. So there is a remove migration, which will undo the changes I have made. So it should remove the last migration. Okay, so now hopefully the other demos will work. So that's data seeding. In a summary, it just takes your data and includes them in the migration code, so you don't need to write your own SQL to seed data in the database. And it can detect changes, so if you change something in the data, it will generate the update expression. And also, the other way for reverting the migration is also implemented, so this should work, and it's a quite nice solution. Okay, so lazy loading. Few people raised their hands that they want lazy loading back. So Microsoft worked on this feature, and they tried to make lazy loading better than in EF6, which I think they quite accomplished. Okay, so this feature was both loved by some people and hated by some people because it's convenient if you don't care about performance, or if you work with small data, or in some applications it is not a problem to use lazy loading everywhere. But of course, if your database is huge, it's not a good practice to use lazy loading, because you never know, or it's not clearly visible which command will produce which SQL query. So you need to use profilers and things like that. There are other ways of loading. We all know eager loading. So in EF Core, this was present since the first version. So you can say include and include some related properties. There was an extension. There was a then include, which can include another table which is related to the posts. So you were fetching the block, the posts, and all those comments. So basically, you will cache all the entire database in memory. And there was also explicit loading. When you loaded the block entity using any method, you can say context entry and use collection and say load. This is explicit loading, so this will load the collection when you call this command. So you need to explicitly say, I want to load this. And of course, Maybe you don't need all columns from the posts, you need only some of them, for example, the post titles. So always better is use projection and select the only things you really need. Yeah, because you will transfer much less data between the database and your server. So these are the current methods. And now in EF Core 2.1, there is the lazy loading feature. So you need to turn this on explicitly. And you also need to install a package if you want to use lazy loading proxies as were used in EF6. So by default, it's not turned on. You have to turn this on explicitly. And the easiest way for this is to install Microsoft.entityframeworkcore.proxies, which is a separate package that implements everything lazy loading really needs. There is another way I will show you, and you can use lazy loading only on some places, only on some entities or some properties, and you can wire all the infrastructure by yourself, so it won't generate proxy classes, as we will see. Okay, so let's look at the demo. So lazy loading. Okay, so I have some infrastructure stuff. I have created a SQL query logger provider, which I will plug in the entity framework DB context, so it will print out all SQL queries in the console window, so we will see what communication between the application and database is present. Okay, there is SQL logger. I'm just filtering one event with the actual SQL query and typing it on the console. So this is wired up here in the on configuring. So I'm saying options builder, specifying the default connection string. Again, this should go to the configuration. And you need to install the lazy loading proxies package and say use lazy loading proxies. By this, you will enable lazy loading. Also, I'm using use logger factory, and I'm providing my own logger factory, so all the SQL commands will be printed out on the console. So this is the plumbing, and this is just generated from the database from the previous project, so the database is exactly the same. I haven't done any changes, except of one. All the navigation properties needs to be virtual. Otherwise, the proxies wouldn't work, because what the lazy loading does by default is it will generate a class which inherits from the block class and override the getters and setters of the navigation properties with their own code. Yeah, so instead of using the block class, the entity framework will create some block proxy class, and it will use that. And the lazy loading is done because this is virtual. If this is not virtual, you will get an exception that the lazy loading cannot inject its own functionality into these classes. Yeah, so this is the change. Because in EF6 there was no exception, it just didn't work. Here you have to use virtual on every navigation property. Maybe this will change, but this is the current state. Okay, so let's look at the program class. It's very simple. So I will load a block with ID equals 2, because it has some posts and things like that. So, and now I say block.posts, which should lazy load the posts for my entity. Yeah? So we will see that this works. And I'm also loading some post and working with commands. And I will take the first command and print out the type of the actual object. So you will see it's not in my namespace efcore121.lazyloading.model, but it will be in other class because it's the proxy. Yeah. So let's run this, and we should see two queries. Okay, so the first one loaded the block with ID 2, and when I touched block.posts, it generated another query. So I'm selecting the posts, and there is the parameter block ID, which is provided by Entity Framework. And now I have printed out all the block posts I have. And now let's load the command. and see the actual type. So this will load the comments. So there will be next query. Yeah, I'm loading the comments. And you can see the type of the entity is not comments. It's some castle.proxy's comments proxy. Castle is a library they are using to implement, to create these proxies and runtime, Castle Dynamic Proxy. So that's why it's in the namespace castle.proxies. But it inherits from the comment, so on every place you are using the comment type, this object will work too. Yeah? But it's generated at runtime. Okay, so this is the default way. It's not very difficult to use. So if you like lazy loading, just install the Microsoft Entity Framework Proxies package, turn on lazy loading, and it will work. Yeah, so use lazy loading proxy. This is the magic option to turn on. And if you want to use lazy loading but not with the proxies, it's possible. So I have the same, basically the same code, the second part of my previous demo. So I'm also loading the post, and I'm working with the comments. But let's look at the comment entity. Or sorry, the post entity. So I'm not using virtual here, but I'm implementing the getter and setter in my own way. So I have two constructors. This is public one. I will use it when I'm creating a new post and things like that. And the second one, that will be used with Entity Framework, and it accepts the iLazyLoader object. So Entity Framework will provide you a service that can be used to do a lazy loading, which is a great extensibility point because it is possible to supply your own lazy loader. So if you think your own strategy of lazy loading entities, maybe with some caching or things like that, it's pluggable. So you can plug your own lazy loading, which can be more efficient, for example. Yeah, it depends. Okay, so this is classic EF core. And here the comments is a navigation property I want to lazy load. So as you can see, I'm in the get. I say lazyloader.load the current entity and the comments, and it's passed by reference because the lazy loader will set the underscore comments private field. And if I set the comments manually, it will just assign the value to this field I've declared at the top. And basically that's it. Entity Framework will always choose the constructor with more parameters. So even if there are two constructors, Entity Framework will choose this one, so we will have the lazy loader. But if you create the post manually, you will not have the lazy loader. So this code, which uses the lazy loader, must always be agnostic. It can be null. Yeah, so use the question mark, and you will be all set. And the lazy loading, of course, doesn't work on new entities which are not attached to a particular data context. So this will work. And you can, as you can see, I have only set up lazy loading on comments, not on this property. So you can choose where you want to lazy load. If there is a risk that this will fetch a lot of data, you can just not implement lazy load on this property because it's not safe. Yeah, so this is more flexible, and you can also inject your own lazy loader. Okay, so that's manual lazy loading. I can run this, so you will see that the output type will be my own class, not the castle proxy. I don't even have this package installed in my project, so there's no way how Entity Framework could make a proxy. Okay, so you can see also the two SQL queries that are the same as in the previous example, but this comes from my namespace, so it's mine class. Okay. Let's move on. You saw that I can specify multiple constructors, and the constructors can have some parameters. And EF Core 2.1 allows you to use parameterized constructors, so you can add another parameters to the constructors, and Entity Framework Core will provide the data. It will inject the values in the constructor. So if you, for example, want to create a block only with a constructor which has the block name parameter, you can use this from EF Core 2.1. So it works by naming convention. You can take the properties of the entity, just make the first letter lowercase, and use these parameters in the constructor, and Entity Framework will bind them automatically. If the parameters is not present in the constructor, it will use the setter. But if it's present in the constructor, EF Core will pass the value directly in the constructor. So it makes your API a little bit nicer. You cannot allow the, for example, you can deny creating an instance without some properties being set. Yeah, so you can say, whenever creates block, he must specify the block name, because it's in the constructor. Yeah, so that's, and EF Core will respect this, of course. Okay, so also you can use another types of the parameters, for example, the iLazy loader, or DB context, but it's not very nice, or iEntity type, which will give you metadata about your type. So these are the things you can put in the constructor. Okay, so let's look at the demo. Okay, so I have put this constructor in my block entity. So everyone who wants to create a block must specify the name. It cannot be, this entity cannot be created without the name. So I'm just setting name equals name, which is great. And notice that I have set ID to private set. It's also quite nice because this won't allow the users to change IDs of the object. They will be able to read it, but they cannot change the ID. But because I'm using private set and Entity Framework uses reflection to set these fields, Entity Framework will be able to call this even if it's private, because he can cheat with the reflection. Of course, you will be able to set this using reflection too, but who would do this? Yeah, so the ID is read-only. It can be assigned by Entity Framework, but in your application code, you will not be able to set it unless you will cheat. So this makes your model more strict in terms of what properties can be set by the developers and what cannot. And it can, the API can be richer than normally because of this. So this is one thing you can do. The other thing, you can create another constructor which will give you iEntity type. This is a different service you can inject in the constructor. And this can give you metadata about your type. So if you, for example, need to access your primary keys dynamically, this class will help you with this, because the entity type contains a lot of information about your type. So mapping to CLR type, base type, and there is, for example, find foreign key, foreign index. So this will give you metadata about your model. So if you need to implement some, for example, generic interface or something like that, this allows you to get metadata about your types. For example, find primary keys. Yeah. So this is also quite nice, but also you need to be agnostic, because if you create the post manually with no parameters, then you will not have the metadata. Yeah. So, but if you load the entity using Entity Framework, this will work. Yeah, so this is the entity type you can use. And in the future, we can expect more and more services being able to inject in constructor parameters and implement more features. Yeah, so this is just the beginning. You can use the, as I said, you can use DB context here, but it's not a really good practice to do because it's too strong dependency. You're giving Bianco dependency to do anything with the database, which is not a good design. Okay, so this is parameterized constructors. And the next feature is value conversions. Who has been using enums in your model? Okay, quite a few people. And as you know, if you use enum in your model, it will map to integer field in the database. There was no other way in EF6 until now. And EF Core until now. So you can define some conversions on a field level. So you can say this property will be stored in a database, not using the default way how EF Core would do that, but using your own logic. It works for one property, so you cannot combine 3 columns in the database into one property, but I think that's the direction where we will be in the future. But currently you can say, for example, this is enum, but in a database I want to have string, string representation of the enum. Or, for example, this is Boolean in my application, but for some reasons in the database it's big int. So you can do these conversions. Or it can be just char with y or n or something like that. So there are a lot of built-in converters. If you look in the documentation, it's one screen of converters. I have listed some interesting ones. So for example, there is bool to 0, 1 converter. So in the database, it will be integer or something like that. But in your model, it is Boolean, true, false. And this converter will do the mapping automatically for you. And it's extensible, so you can build your own. Enum to string converter is the one I have been talking about. So if you have enums and want to represent them as strings in the database, this is the converter you want to use. Also the time span. If you try to use the time type in the SQL server, there is a limitation that the time cannot be greater than 24 hours, which is quite an annoying limitation. But if you use time span to ticks converter, the ticks can be mapped to a long field, and there can be any time interval used. So this lets you build rich models and define the mapping on the database. You can define your own mappings, as we will see in the demo. OK, so let's use this. OK, so in the previous demo, if you look at the comment, there is a property called type, and it's a string, because in the database it's a string field. But in this one, I have changed that. So this is enum, comment type, and there are several options. So there is question, general, or suggestion, or something like that. And if you look in the on-model creating, I have added this one. We are working with the comments table, and the property called type, you say has conversion and pass new converter. So this is the converter which can take enum of this type and convert it to string and back from the string to enum. And if you want to use another conversion, you can specify your own, so you will get 2 lambdas from the model to the database. So I'm saying any author name I have in the model, I will trim the white space from the back and from the end, and also convert everything to uppercase. For example, this is a sample. And because this is the only way how the data can get in the database, I don't need to do any conversion on the way back from the database to the model. So you can use this for many use cases. For example, transparent encryption of data. You can encrypt the property before it's stored in the database and decrypt it when you load it back. There's a lot of use cases you can do, or for example, store binary data as base 64, because it's more convenient to work with strings than with binary data, and so on. So this gives you a lot of opportunities to make the model more usable and rich. OK, the last feature I will be talking about, I have a few minutes, is group by translation. Who has been using group by in EF Core? Who has tried to use it? And who found out that it evaluated in memory? It will load the entire table, and because of the client evaluation feature, which basically means that if there is something EF Core cannot do, it will just load the data and do the rest of the query in memory. So group by was evaluated in memory, which is a huge problem in any real-world scenario, because you don't want to load 10 million of records and load everything in memory, then do some sorting to make the group even possible, and it's annoying. So the Entity Framework Core team is working on the group by translation. It's not perfect, as you will see in the demo, but it can be used at least for the basic scenarios. Okay, one important notice, always check what SQL this produce. Because if you use something non-trivial in the group by, it will most probably end with a lot of queries instead of one big query. Yeah, so let's look how this works. At first, I have a project where I have EF 2.0. So this is running the old Entity Framework 2.0. Entity Framework Core 2.0. It's, I'm saying old, it's the stable version, it's the newest one, but still, this is the, so the context is still the same, and here I have my query. So I am taking the blog posts, grouping them by block, and building some report items. So there will be a block name, number of posts in the block, so p.count, latest post, latest date of the post, so maximum of the post publish dates, and maximum number of comments in some post, most commented post from the block. Yeah, and this is the problem because this is too complicated for the query translator. So this cannot be translated, and also because from the group by down, it's happening in memory, so this will produce another SQL queries. So in EF Core 2.0, let's look at the queries. Okay, so you will see there's a lot of queries. Okay, so the first one is the beginning of the query until the group by. The group by is done in memory, so it will just load all the blocks, all the posts, and grouping is done in memory, which is bad, because you are loading much more data than you actually need. And when I'm in the for each loop, and when I touch the comments, the maximum number of comments in the posts, as you can see, this loads all post IDs from the comments table without any filtering, because the filtering is also done in memory. So these are 4 queries that can load millions of records. This is unusable in any real-world scenario. Okay, and of course, this is select n+1, because the number of blocks or number of posts there will be the number of comments queries. So if you load million posts, you will have million queries for the comments. Huge issue. Okay, so let's look how this improved in EF Core 2.1, and don't be too enthusiastic. I need to lower the expectations. Okay, so not so much better, but the first query, yeah, but at least it's filtered. Actually, this is strange because there is no group by. Okay, so, okay, they cannot translate even this, but I don't think I have changed the query multiple times. So yesterday I had the query with the group by. It's not here now, but still, the problem is that there is also select n+1. This won't be addressed in EF Core 2.1, as they say on GitHub. So you need to use different way of querying this data, because if you use another aggregation after the group by, which is this one, it's difficult for them to translate, so they won't do this. Okay, but at least the n queries were filtered, so you are not retrieving so much data. Oh, maybe. Okay, this is the correct file. Okay, I have tried to rewrite the query so the group by will get all the aggregations it will need. So anything complicated would be after the group by. And it's even more interesting because if I use this, so I have get the number of comments per each post before I'm doing the grouping. So I try to help EF Core to get all the data before the group by so it can do the aggregation. And this would generate the group by, but there is another issue. So if I run this, let's see what happens. Exception. It generates this, which is not valid SQL syntax. It just generates wrong SQL that SQL server cannot interpret. Yeah. So this is an issue, and I wouldn't be. That's why I said I wouldn't be so enthusiastic about group by translation, because right now in the preview 2 of EF Core 2.1, it's still not fixed. This issue is present on GitHub. I have tried to report it, then I found that it's a duplicate because somebody reported this a few days ago. Because the preview 2 is here from Wednesday, it's a very new release, so there are still some issues, and it's a preview, so I understand that they need to test everything, but it's still open, and if you read through the discussion, even there is no clear statement from the EF Core team if they are going to address this or not. So the group by translation will probably work in final version of 2.1, but only with the few basic query features, not everything. It's not so durable as EF6, because you could use very complex queries and it would be translated. Here, it's still very early, and they don't have the ambition to make so complex query translator. Okay, so last slide. Is it ready yet? Who thinks that EF Core is ready for their applications? Do you think that EF Core, are you satisfied with EF Core in your apps? Okay, few hands. Okay, I think that it depends, it really depends on the type of the applications. If you are building a large enterprise system with very complex reports, very complex queries, it's possible with EF Core, but you will probably write every complex query in SQL. Yeah, so it's possible. EF Core is faster, at least from the point of application startup and things like that, but forget about complex queries. On the other hand, a lot of applications today are being written as microservices or just small apps with a small database with few tables, and then EF Core makes much better sense, because in microservices, typically every microservice has its own data storage. It even doesn't have to be SQL, so some microservices can use SQL, some microservices can use some document DB or something like that. So in these small scenarios, EF Core is much better because it's lightweight and faster on startup, which goes really well with the microservices architecture. So if you want to use it in complex applications with difficult queries, let's wait a few more versions until this is ready for the use case, or just use Entity Framework 6. It's supported, there will be new features, new releases, and things like that, but it's slower because of the old and monolithic code base. So that's the conclusion. If you have any questions, let's ask, let's talk, and also there will be another session in the afternoon, then you will be able to ask me anything. But I'm here all day, so catch me anywhere and ask whatever you want. And if you ask, you will get a t-shirt.
Yeah, that's right. The thing is, we ran out of time, but let's do 2 questions, I think, and then the left on the speaker's corner or during the break. Okay?
Okay.
So who is?
Hello. Maybe you know the EF Core dev team have some plans to implement some native and simple way for use designing, like separated methods for model building and migration mechanism support for views and other. Thank you.
I haven't seen anything about this because if I understand the question correctly, you want to have the database modular, some small modules, so all the database doesn't need to be one DB context, one migration, and things like that. I think this is very oftenly requested feature, but I haven't seen any plans on their GitHub to address this yet. I think that because the microservices are a really large buzzword today, I think that they will even separate the databases, or at least database schemas or something like that. They are not thinking about one big database with several contexts. It's possible, but you will have the problems with migrations because they have one table for migrations in all database. It can be configured to use different table names, so this is how you can work around this, but I don't think it has ever been supported scenario, unfortunately.
Thank you. And one more question. That side. I'm sorry, maybe in the break.
What about XML converters? For example, I have XML column in database, then I want to map it to model on the backend.
I don't remember if the value converters for XML were present, but it will be very easy to write your own. The only issue is, of course, if you do some transformation on the SQL, it cannot be translated to SQL query. Yeah, so if you want to select some nodes from the XML, EF Core will not be able to translate this to SQL. So, but if you just have XML data in the column and you want to work with X document or XML document on the client side, yeah, that's exactly what value converters are for. The same applies to JSON. Yeah.
Thanks.
Okay, you're welcome.
Thank you very much. Thank you, Tomáš, for your amazing talk. Thanks for coming to our conference. This is for you.
Thanks.
So let's applause.